Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to try and wrap up this discussion we've been having about completing the square. And the reason I've taken time is because you probably are not going to see this technique taught at school. You'll not be even required to use this technique in your exams at school. This technique I took some time is because this is the basis of quadratic equations. It's because of this particular technique, the geometrical approach to completing the square, a quadratic equation is called a quadratic equation. Otherwise, we have every other polynomial equations named by its degree. But a quadratic equation is called a quadratic equation because of this quadris method. So let's try and wrap up this discussion. The reason I call this question a level 5 question is because of that first term where a, the coefficient of x squared, is not equal to 1. In all of the earlier questions, we saw the value of a, the coefficient of x squared, was equal to 1, even in level 4 question. And yes, when we multiply that equation by 2 and then by 4, it kind of becomes like that level 5 question where that value of a is more than 1, right? However, if you notice, this value of a here is 4. And in our question that we're dealing with today, which we've called a level 5, that value of a is an odd number. Now, it's not the problem that it's an odd number that's an issue, but we need to be careful what that term represents, what that first term represents. And to illustrate that, I have this geometric shape today. I use the tools from OneNote. I did not sketch it, but a couple of things we need to point out. Okay, this is the entire square. Okay, it's broken up into two perfect squares. All right, two perfectly smaller squares. So the largest square is broken up into two perfectly smaller squares and two identical rectangles. These two rectangles are of equal area. Now, if this first piece was x squared, the area of the first piece was x squared, it would mean that this side is x, right? That means the sides of the square are x. X times x would be the x square. And that means this adjacent rectangle, its side, this side is also x, right? This side is also x because that's the side of the square also. They share the same side. And if the other side of the rectangle was b or a, that means this would be x times b. And because these two rectangles have to be congruent or having equal area, this also has to be x times b, which means this is also b. All right. So this one rectangle also shares the same side as this other square. So this is one perfect square, and this is going to be the other perfect square, whose area then is going to be b times b, which is b square. So this is one square. This is a second square, a perfect square, and these two are going to be identical rectangles in area. Okay, both the areas are going to be equal. Clear? Now, why is that important? Because this first term comes from this first term. That means this term needs to be a perfect square number. So a 9x square would be good, a 4x square could be good, a 16x square would be good, a 25x square could be good. Now, why am I saying these things? These are the hints to keep in mind when you're completing the square. Therefore, I explained this needs to be a perfect square number. So think of those kind of numbers when you're trying to multiply the equation. That's the clue, okay? This one will automatically produce itself, but this is the key thing to keep in mind. And we also saw in the earlier video that the second term needs to be even. And the reason it needs to be even is because that's when it's easily divisible by 2, right? Because then you have these two rectangles easily divided by 2. They'll have equal areas, okay? So those are friendlier numbers to consider. And so those are the tips to consider, that if you have the first term of your quadratic a perfect square and the middle term to be an even number, then you're cool. All right, let's try and do that. Okay, so if I were to multiply this by 3, because then I'd get a perfect square, right? 9x squared. So if I were to go and multiply this equation by 3, okay, so this is multiplied by 3, what would I get? I'd get this as 9x squared. That kind of solves this issue, right? So you've got a 9x squared, which means this would be a 3x and a 3x. As you can see, 3x times 3x is 9x squared. However, what happens to this middle term? 3 times 7 is going to give me a 21x, and that's an odd number. Let's try and go ahead and see what's going to happen. So 3 times 4 is going to be a 12. That's okay. And 3 times 12 is a 36. All right. So this is the equation we've got. We've kind of handled the first piece, which means we've got a perfect square, but then we want an even number here. Yes, we can go ahead and make it negative 21 by 2, but just as we saw in the earlier video, let's try and make it a friendlier number. Now, if I multiply this by 2, this equation, entire equation by 2, this will become even. However, this will become 18. Can you see that? That is why this is a level 5 kind of a question where you need to think of the numbers that will preserve the first term as being a perfect square while at the same time give you the middle term as even. All right? I'm going to repeat that again. You got to think of numbers because look, when I multiply this entire equation by 2, this will become even. Okay, this will become 42, but this is going to become 18. Not a good number, right? So what is that number that we need to multiply this equation by, which will preserve the first term as a perfect square? Why do we need a perfect square? We already explained that, right? So we need a perfect square number here for the first term and an even number here. How do we do that? Well, now this equation, if I multiply this by 4, yes, the numbers will become big, but hold on. The principles of geometry are going to support this method, okay? I'm going to multiply this entire equation by 4, and I'm just going to erase whatever I had here, right? So that it'll clean up the space to enter the new numbers. Here we go. Here we go. I've erased that, erase that. And now when I multiply the entire equation by 4, I'm going to get 36x squared as the first term. That's a perfect square, right? Look at that, 36x squared. We've got that. That means this is going to be 6x and this will be 6x. Brilliant. Now, what is going to happen when we multiply the second term by 4? Well, this is going to be equal to a negative 84x. And that's an even number. We wanted the middle term to be even so that it can be equally divided. These two rectangles need to have equal areas, need to be equally split. And we also wanted the first term to be a perfect square. We've got that. And we've got the even number, which can be equally split as negative 42x out here and negative 42x out here. Equally split. Negative 42 add up to negative 84x. Brilliant. Now, we work out what's going to be the side then. Okay. So if we have 6x here, what should we multiply by 6x to give us a negative 42x? That's going to be negative 7. Negative 7 times a 6x would give you negative 42x. And because it's a square and a square is a symmetric object, this also will be negative 7. Why? Because 6x times a negative 7 will give us this negative 42x. So that's taken care of, which means the area of this piece out here, the mystery number as we called it in the last video, that's negative 7 times a negative 7, that's going to be equal to a 49. 49 is going to be that magic number, that mystery number, or whatever you like, whichever word you like, that's 49. But what do we have here? Let's multiply and see. So 4 times 12 will give you a 48. No problem, we can adjust, remember that? And we need to also multiply this constant term here. 4, 6 is 24, 4, 3, 12, 13, 14. So that's going to be 144. Sorry, why did I write 146? That's a slip of the pen, okay? 4 and 6, 24, 4, 3, 12, 13, 14. Okay, that's good. Now, we've got a 48, so I'm just going to write this equation here. This is 36x squared minus 84x plus a 48 is equal to 144. All right, we got the third piece to be 49 and we have a 48, but we said no worries. Okay, we can add a 1 here, and because we are adding a 1 here, we need to add a 1 on both sides of the equation. That means we've got the equation. This is the area. Remember, this is the area of this particular square. All the pieces put together, okay, 36x squared, negative 42x, and a negative 42x give us a negative 84x, 49. That 48 plus 1, 49. So the left-hand side of this equation represents the area of a square whose side length is 6x minus 7. So this left-hand side can be written as 6x minus 7. The whole square is equal to 145. And that reduces to a level 2 question. We have done this before. So we can take the square root on both sides and say 6x minus 7 is going to be equal to plus or minus the square root of 145. And then it's all about solving for x by saying 6x is 7 plus minus the root of 145. And x must be equal to 7 plus minus square root of 145, the whole thing divided by 6. So what are the main highlights from this example? Well, it comes from this geometrical shape called the square. What did we understand? We saw that this shape out here, this first piece of this entire square, it should be a perfect square, okay? That should be a perfect square number, and these are identical rectangles. What does that mean? Well, in that equation that's given to us, we need to multiply that equation by a number which will make this first term a perfect square while keeping the second term as an even number. Okay, that can be a challenge, and therefore it is called find those mystery numbers that will complete this square. I hope that these videos will be useful to you in your own understanding of quadratic equations and will make you a lot more curious to find out more about quadratic equations. But before we close, one final thought. This method of completing the square, this is the very method that is used to derive that quadratic formula. Yes, you heard me right. It's the completing the square method that is used to derive the quadratic formula. I'm going to see you all in the next video.